Hi friends, welcome back to our YouTube channel, one and only pharmacy. So friends, in today's video we see detailed notes about and explanation about chapter Emulsion, Pharmaceutics second, the Pharmacy second year, presented by one and only pharmacy YouTube channel. So friends, please watch this video till the end. Let's start without wasting our time. Topics covered under this video. Following topics we are covered in today's video, which are these are definition, emulsions and emulsions, types of emulsion, identification test of emulsion, emulsions and their classification. Emulgent means emulsifying agents. Next point, methods of preparation of emulsion, instability in emulsion, HLB and its importance. This point we are cover in today's video. Let's start one by one in detail. Emulsion. Definition of emulsion. Emulsion is a biphasic dosage form. Emulsion is a biphasic dosage form in which two immiscible liquids are mixed, one of which is distributed throughout the another in a minute globule, and the system is stabilized by addition of third substance known as emulsifying agent. Emulsion is a biphasic dosage form in which two immiscible liquids are mixed, one of which is distributed throughout the another in a minute globule, and the system is stabilized by addition of third substance known as emulsifying agents. These are the definition of emulsions. Types of emulsion. There are two types of emulsion. Oil in water, that means O by W, and second, water in oil, that means W by O. In first A, oil in water, O by W. In this type, the oil is a disperse phase and water is a dispersion medium. That means oil is in a low quantity and water is in a large quantity. Oil is distributed in water and make a emulsion. And second type, water in oil, means W by O. In this type, the water is disperse phase and oil is a dispersion medium. That means water is in a small quantity and oil is in a large quantity. That means water is distributed in oil media and form a emulsion. Second point, identification test of emulsion. There are four tests for identification of emulsion. These are dilution test, second staining test, third electric conductivity test, fourth fluorescence test. These are the four tests which we are used for the identification of emulsion. Let's see one by one in detail. Dilution test. The principle behind this test is that unlimited addition of dispersion phase into emulsion does not break the emulsion, but addition of disperse phase will break the emulsion. Example, in O by W, that means oil in water, emulsion remains stable upon unlimited dilution with water, but unlimited addition of oil will break the emulsion, because in O by W, water is a dispersed medium. We are adding how many times uh, water, but there is no disturb or break the emulsion. That means it's a water oil by water type of emulsion. And second, water by oil emulsion remains stable upon unlimited dilution with oil, because it is a oil is a dispersed medium, but unlimited addition of water will break the emulsion, because water is a dispersed phase. That means it is in a small quantity. These are the dilution test. Let's see once again. The principle behind this test is that unlimited addition of dispersion phase into emulsion does not break the emulsion, but addition of disperse phase will break the emulsion. Second, staining test. This test can be performed by using either first oil soluble dye, that means scarlet red dye, and second water soluble dye, that means safranin. During the preparation of emulsion, triturate scarlet dye with emulsion. Take a drop of such a emulsion on a glass slide and observe under microscope if there are two possibilities. First, red dispersed globules are seen on a colorless background, then it is oil by water type of emulsion. And second, colorless dispersed globules are seen on a red background, then it is water by oil type of emulsion. A red background because of a scarlet red, and it is a water in oil type of emulsion. These are the staining test for identification of emulsion. Third test, electric conductivity test. The principle behind this test is that water conducts the electricity while oil does not. It's very common. Water conducts the electricity and oil does not conduct. Thus, oil by water type emulsion will conduct the electricity because water is the continuous phase. Second, water by oil type of emulsion neither not conduct the electricity because oil is a continuous phase. Oil is a continuous phase and does not conduct the electricity. That means it is the if electric conductivity is passed, then it is a oil by water type of emulsion because water is continuous phase, and if does not pass electric conduct, then it is a water by oil type because oil is a continuous phase. Fourth test, fluorescence test. Many oils when exposed to UV light give fluorescence. Many oils when exposed to UV light give fluorescence. Is a drop of such emulsion is observed under microscope using UV light, and if entire field gives fluorescence, then it is water by oil type of emulsion because oil give a UV light exposed give fluorescence in the presence of UV light, and if emulsion shows spotty fluorescence, then it is a oil by water type of emulsion because water does not show the fluorescence. Second point, emulsions, or also called as emulsifying agents. We are seen in definition. What is the definition? One substance, one phase is added into the another. That means two immiscible liquids are mixed by the addition of third agents. That third agents are called as emulsifying agents. Without emulsifying agents, there is does not formation of emulsion. That means emulsifying agent is the necessary for preparing emulsion. Let's say definition. The agents which stabilize the emulsion are called emulsifying agent. The agents which stabilize the emulsion are called emulsifying agent. Classification. There are three main classes: naturally occurring emulsions, semi-synthetic emulsions, and synthetic emulsions. Let's see one by one with examples. First, naturally occurring. There are three subclasses. First, plant source, example acacia, tragacanth. Second, animal source, that means beeswax, gelatin. Third, mineral source, that means bentonite, magnesium oxide, etc. Second, semi-synthetic, that means prepared in a laboratory. Example, polysaccharides, methyl cellulose, and ethyl cellulose. Third, synthetic, anionic. Example, soap of divalent metals, sodium lauryl sulfate. Second, cationic. Example, cetrimide, benzalkonium chloride. Third, non-ionic. Example, twins. The fourth, ampholites. Example, dicyl alamine. These are some examples of emulsions. Emulsions or emulsifying agents means the agents which stabilize the emulsion. Second point, ideal properties of emulsifying agents. First property, it should be surface active. Second, it should reduce surface tension below 10 dyne per centimeter. Third, it should be absorbed quickly around the dispersed phase globules by forming a complete coherent film. Fourth, it should increase the viscosity of emulsion. Fifth, it should be non-toxic. Sixth, the odor and taste should be compatible with the preparation. Seventh, it should be chemically compatible with other ingredients of the preparation. These are some ideal properties of emulsifying agent should must have. Let's see once again. It should be surface active. It should reduce surface tension below 10 dyne per centimeter. Third, it should be absorbed quickly around the dispersed phase globules by forming a complete coherent film. Fourth, it should increase the viscosity of emulsion. Fifth, it should be non-toxic. Sixth, the odor and taste should be compatible with the preparation. Seventh, it should be chemically compatible with the other ingredients of the preparation. These are some ideal properties. Next point, methods of preparation of emulsion. There are two methods. First, wet gum method, and second, dry gum method. Let's see wet gum method in detail. In this method, mucilage of acacia is made. First, primary emulsion. That means triturate acacia with twice the quantity of water. Triturate acacia with twice the quantity of water as that of acacia in a mortar to form a mucilage. Measure out required quantity of oil and add dropwise into the mortar with trituration in one direction until primary emulsion is formed. The crackling, that means chit chat sound, indicates the formation of primary emulsion. The crackling chit chat sound indicates the formation of primary emulsion. Until chit chat sound is not produced, then we triturate in one direction. Second stage, dilution of emulsion. Emulsion is diluted up to a prescribed volume by adding slowly the external phase with trituration. These are the wet gum method for preparation of emulsion. Second point, difference between wet gum method and dry gum method. Let's say first wet gum method. First point, mucilage of acacia is used. In dry gum method, dry acacia is used. Second point, oil is added dropwise. In dry gum method, whole quantity of oil is added at a time. Third point, primary emulsion is viscous creamy in nature. In dry gum method, it is thick and oily in nature. In fourth point, it is a relatively slow process. In dry gum method, it is quick process. In wet gum method, fifth point, all apparatus are not required to be dried because it is a wet gum method. In dry gum method, all apparatus should be dried like mortar, pestle, etc. because it is a dry gum method. It is a simple difference between a wet gum method and dry gum method. Second point, next point, instability in emulsion. Instabilities in emulsion are three. First, creaming in emulsion. Second, cracking of emulsion. Third, phase inversion or phase reversal. Let's see one by one. Creaming in emulsion. What is creaming? Creaming is nothing but the formation of relatively concentrated layer of emulsion from the original. Cream emulsion can be performed by shaking because cream is a relatively concentrated layer of emulsion. This layer can be broken into small globules by shaking. The creaming will take place at the top or the bottom depending upon density of dispersed phase. That means in creaming of emulsion means there are two phases are separate out. Upon shaking, these two phases are mixed with each other. It's not a hard type of instability. Cracking of emulsion. Cracking of emulsion means separation of dispersed phase as a separate layer which is not redispersible upon shaking. That means it is the one of the type of creaming, but it is not dispersed with the help of shaking. Cracking of emulsion may be caused by changes in the nature of interfacial film of an emulsifying agent. Phase inversion. The phenomenon of conversion of O by W type of emulsion into water by oil type of emulsion is called phase inversion. That means phase inversion. The phenomenon of conversion of oil by water type is converted into the water by oil type is called as a phase inversion. That is conversion of dispersed phase into continuous phase and continuous phase into dispersed phase. The addition of any substance that alters the solubility of emulsifying agent may cause phase inversion. Second point, HLB and its interpose. HLB means hydrophilic lipophilic balance and its importance. Let's see HLB about. Uh, HLB means hydrophilic lipophilic balance. Griffin in 1949 devised a useful method for calculating balanced mixture of emulsifying agent to provide a particular type of emulsion, which is called a HLB method. What Griffin devised? Griffin in 1949 devised a useful method for calculating balanced mixture of emulsifying agent to provide a particular type of emulsion, which is called HLB method. Surfactant molecule emulsifying agent shows two parts. First, hydrophilic part, that means affinity towards water. Hydrophilic, hydro means water and philic means loving. That means hydrophilic means water loving. affinity towards water. Second, lipophilic part, affinity towards oil, that means lipid loving. Generally, emulsion having HLB numbers below 9 produce water by oil emulsion, 9 to 11 are intermediate, and above 11 produce oil by water type of emulsion. Importance of HLB scale. Why HLB scale are introduced in 1949 Griffin? There are some importance. It plays an important role in formulation and stability of emulsions. It has a value in non-ionic type emulsion. It is useful for selecting emulsifying agents. It is useful to avoid the problems like creaming and cracking. Thank you guys. Do like, share, and subscribe to our YouTube channel for pharmacy related daily videos. And please subscribe our channel, one and only pharmacy. Let's see once again what we learn in today's video. Importance of HLB scale. First, see HLB. HLB means hydrophilic lipophilic balance. Griffin in 1949 devised a useful method for calculating balance mixture of emulsifying agent to provide a particular type of emulsion, which is called the HLB method. Surfactant molecule shows two parts: hydrophilic water loving and second lipophilic water lipid loving. Generally, emulsion having HLB numbers below 9 produce water by oil emulsion, 9 to 11 intermediates, above 11 produce oil by water type of emulsion. There are three instability in emulsion, which are creaming in emulsion, cracking of emulsion, phase inversion. In creaming in emulsion, that means separation of two phases depending upon density, downward or upward. If density is low, then it's upward, and density is higher, it is a downward. Upon shaking, we are redisperse creaming. That means it is not a major problem. Second, cracking, that means it is also separation, but it's a hard type that we does not redisperse upon shaking. And phase inversion means oil by O by W type is converted into the W by O. That means continuous phase is converted into dispersed phase, and dispersed phase is converted to a continuous phase. These are the three instability. There are the difference between diagram method and weightogram method. It is the processor of weightogram method. That means there are two methods of preparation: weightogram method and diagram method. Ideal properties of emulsifying agent. There are 7 ideal properties. It should be surface active, surface tension below 10 dyne centimeter. It should be adsorb quickly around the redisperse phase. Classification of emulsifying agents. Definition: the agents which stabilize the emulsion are called emulsifying agents. There are 3 types: naturally occurring, semi-synthetic, synthetic. There are 3 tests for identification of emulsion: dilution test, staining test, electric conductivity test, and fluorescence test. Types of emulsion: oil in water, water in oil. Oil in water means oil is a continuous dispersed phase and water is a continuous phase. Dispersed phase, that means small quantity, and continuous phase means it's large quantity. Definition of emulsion. Emulsion is a biphasic dosage form in which two immiscible liquids are mixed, one of which is distributed throughout the another in a minute globule, and the system is stabilized by addition of third substance known as the emulsifying agent. So friends, in today's video we see study about following topics: definition, emulsion, emulsions, types of emulsion, identification test of emulsions and their classification, methods of preparation of emulsion, instability in emulsion, HLB and its importance. Thank you guys. We are cover about today's topic, emulsion. Thank you.